Hello and welcome to another deep dive. So this time around we're going to be taking a look at the area of serialization. So serialization is a fairly broad area. In general, what it's talking about is taking information that is in memory and then turning that into another form, or taking it from that other form, which might be from a network or from a storage device, into things that are in memory, so deserialization. So in this case, we're going to focus specifically at serialization and deserialization in the context of saving and loading from disk. And so we're going to take a look at some built-in things in Unity for doing that and the limitations of them. And then we're going to also take a look at a couple of ways around that. And in particular, I'll focus there on some free options for that. And we'll also in general have a bit of a look at how we can actually design our data and the different things we need to consider for that. So we'll dive right on into that. If you are finding these videos helpful, then please do chuck another like and subscribe as well. Really, really helps out. So let's dive in. And so I've already got a few things already set up here. And so what I've set up is we've got a system where we can equip different items for a character, and we can add and remove ones, and we can also chuck in a whole different set of stuff. If we look at the data that we've got, then what we've got is in our characters in the scene, we've got these player inventories. So you'll see here what I've done is I've split the data out. So the actual item information is stored within this separate class. It's not held within monoBehavior, the player inventory component. And there's a very intentional reason for that. When we're working with data, it is often easier if we can split it out from the monoBehavior, because there aren't setups there currently which will allow us to go and directly save an entire monoBehavior out. The code will run, but it won't actually give us usable data that is going to allow us to restore the environment. So what we need to do is we need to split our data out from the things that use it. So what I've done is I've split the inventory data into this separate class and stored it like of this. And what I've done is put in properties to help control the access for it. Also means that it allows me to take existing data that I might have here and then patch that up. So it means that it's very easy to migrate stuff over to this kind of structure. So these actual items, though, if we take a look at them, so we have our base item, and we can see it doesn't inherit from monoBehavior, so we specifically mark it as being serializable. We have some general things in terms of information here, and then we have some specific extra customized versions of this. And so what we're going to see is then how we can go about saving this data. So we've got this save load UI. So what we want to do is on save, we want to locate all of the components to save. So we want to have all inventories. We want to find objects of type, player inventory. And then what we can do is we can inventory in all inventories, and then we need to store that data. So, okay, well, let's see if I can, this is not an ideal version, but if I did something like this, player inventory data, inventory data, set that up as a new list, and then let's add these different ones into this. Inventory data, we add inventory dot inventory data. So create a list of our inventory data. And then here we're populating inventory data list. So then to save this out, well, what we can do is one of the common formats that we often will use is this thing called Json Utility. So JSON format ones, Json Utility will convert to them. So we can give it, say, our inventory data. going to turn pretty print on, just because that gives us a version that's going to look a lot easier to read. JSON data. And then, well, we need a path to save this out to. So save file path. So what I recommend whenever you're working with paths is use this system.io.path namespace, because it has a combine thing in it. And the advantage with this is different platforms have different rules for their file paths. They construct them in different ways. So if you use the system.io path, then it ensures that those are going to be correct regardless of what platform you're running on. So persistent data path is a safe location that we can be saving files to. Again, it will be different depending on platform, and that's the idea, is that it's a safe one that we can always use. So we combine that with, and I'm going to create a one that I'm going to call game data.json. And then to output that, we'll do system, IO, file, write all text. We'll give it the file path, so save file path, JSON data, and it'll be done. And I'm also going to log out that save file path just so we can easily see where it is, so we can locate that file quite easily. So we're going to run this, we're going to populate some stuff in there, and we're going to see what this looks like when we save this out, whether it's a case of like, cool, our job's done, it's solved really rapidly. So there we go. That looks pretty good. So we tell it to save. Can grab this file path that it's saving out to. So this is the location it's going from. So then we can open file. We can put in the path. So we've got our game data, and it's empty. And that is a limitation that we hit into with this serialization setup, that if you go and try and serialize just a direct list, it won't work, not with a built-in serializer. What we have to do in a case like of this is create a new folder for our game data, and I'm going to create a file under that, game data.cs. So this, we actually have to create a new one here. It's not based on mono behavior. It will contain a list of player inventory data, all inventories, and we have to mark this as system.serializable. So a list or an array won't directly serialize, but a list within a class will. So what this means is, what we actually do down here is we say, okay, well, I want to, game data is a new game data, and game data dot it was called all inventories is equal to inventory data. And then what I serialize here, what I convert to JSON, is this game data object that's been created. So this is a limitation with that JSON serializer, that you have to embed stuff within a class for it to actually work. But we'll test this. So this one's got a couple of items, and then we save. So let's have a look at our file now. So we can see this time around, it looks a little bit better. You know, we've got one of the ones that has the 2 items, but we don't have any of these extended bits of data. Any of these things with the consumable or the equipable, none of them are there. So one of the limitations with this JSON serializer is it doesn't support inheritance. It won't actually pick up stuff from those different classes. And there are actually further limitations than that, in that this, well, list is all right, but we probably want to know which character it's actually come from. So if I have a dictionary here, and I'm going to rename this inventory data, because we want to make sure we restore it to the right character. We don't want to accidentally put data in a character that it doesn't belong to. So then this becomes a dictionary string player inventory data, then dictionary, and then we store these. What we would be doing is, rather than this, we'd be saying that we want to get the inventory name object name. So we're storing which character it actually is tied to. So let's see how that works. I mean, we already know inheritance isn't working. So it's unlikely that this is going to be something that suddenly now works better. But let's test. Let's see, because we want to be able to restore stuff to the right character. So let's see what we get with this. So I can reopen that file. Let's grab our game data. And now our game data is empty. That's because dictionaries are also not supported. So the built-in serialization setup here doesn't actually support data that has even a fairly marginal level of complexity. As soon as we get to just even the smallest level of complexity, we run into issues and things where it doesn't actually support it. But we've got alternatives. And there are paid alternatives and there are also free alternatives. So looking at a free alternative first. One of the ones is this full serializer by Jacob Default. This is a fairly robust and reliable one. I've used this before. It does support inheritance. It does support more complex data types. It has been designed specifically for Unity. It uses the MIT license as well. This is an excellent, excellent package. And conveniently, I already have it downloaded. So I'm going to add the full serializer in. So we'll bring that into our assets. And now there will be, because this is a bit older, like it hasn't been updated for a little bit, and there have been updates that Unity has made to the testing framework, which means some of these ones, like this expected exception attribute, those don't actually work currently. So I am for now going to comment those out. So there are things like of that where there's a couple of bits that are not fully supported just because of changes Unity's made to their setups. So what changes with this is let's bring in full serializer. So this version is convert to JSON using Unity's built-in methods. So I'm going to get rid of, well, I'm not going to get rid of it, but I'm going to comment that out, but move the back down there. And I'll leave that debug login. So this, I'm going to comment out. So, okay, full serializer has a couple of different things in there. So what we're after in this case, it has this FS serializer. So JSON serializer is equal to a new FS serializer. We've got our new FS serializer. So then we have JSON data is a new FS data. Now what we do is we say, hey, JSON serializer, I want you to try to serialize. And so we can then give it the particular data. So in this case, I'm going to use the typed one. So we can tell it, we want you to try and serialize game data. And then we need to give it the particular instance of that game data. So we give it one that we've created. And then we give it JSON data. So that is going to attempt to serialize, and it will return a result. So result. So we can then, that result, if we want to, what we can do is we can turn that result, JSON data, as string. And so that, if we run this, and then we're going to see how this looks. So we've got our worst case scenario where, in this case, when we were using the JSON data, the Json Utility one built into Unity, we were getting absolutely nothing back in the file. So let's save this. So we're getting an error at the moment. So we can take a look and see what it's actually trying to do. So we can see that it's unable to convert. So the as string is for doing an actual casting of that. So what we have to do is we do Json Printer. So it's got it. So the serialization, the serializer converts it into its FS data format, and then from that FS data format, we can then do particular things. We can take our FS JSON printer, we can produce compressed output, which is not going to be particularly human readable. In this case, I'm going to go for Pretified JSON output, which if we just give it the data, then it will give us back a string. So if we run it with this now, so remember, we're testing with our most complex use case here, where we're using a dictionary with inheritance, and we know that the built-in JSON serialization doesn't actually handle this. Then we go to save. So it has saved. Let's take a look at what we have in our data file. Well, first thing, we can see that it's worked. So we can see here that it's also storing type information. So it works with inheritance. We can see that it's working with dictionaries and complex types. So that is looking pretty good. We've got data being able to be saved out. So then let's make it that we can load the data in. So I'm going to get rid of this. And so what we're doing here is create Serializer and serialize the game data. Construct the output path, and then we are save the data. So okay, well, this output path, that would be helpful to be able to access that anywhere. So what I'm going to do is, this is another good one for setting up something like a save file path. So we might be able to get away with doing that. Now we can just refer to save file path anywhere, and it will just automatically construct it. So that's handy. So first thing we need to do when we're loading is we can check here of, okay, fsystem.io file exists. So we check, do we actually have a file? If it doesn't, we exit, because there's nothing to actually load. Do nothing if there is no file. Then we need to actually read in the data. So system.io file read all text, save file path. So this is our JSON data. So read JSON data. I'm going to actually rename this one here because this is more correctly the serialized data. So JSON is the version that's specifically in the JSON representation. So I'm just going to make sure I'm clarifying the names for these. So we've got JSON data, so then we need to parse that into the serialized form. So what that ends up looking like is we have our JSON parser. So we can tell it to parse. We give it the actual input. So this is our JSON data. And then we need to have a serialized data, which is a new one of the FS data. So the FS data one is kind of an intermediate format that holds the particular information. So we've got that. That will have parsed it from JSON data into our serialized one. So once we've parsed the data, we've got it in a serialized form, but we need to deserialize that. So we can say, okay, well, we need another serializer. So we have our, in this case, I'm going to call it a deserializer because that is the purpose that it's filling. Now we don't actually have a specific deserializer. The serializer does both. But we can say deserializer, try to deserialize to a game data, and we need to give it the particular game data instance. So actually it's a try serialize. We'll try deserialize. So we give that that it's a game data. We need to give it our FS data. So that is our serialized data. And then what we have here is game data, loaded data, loaded data. Now this is passed by ref. And we need to make sure we have given that, set that to null. So this should work. Should deserialize it, but then we need to actually do stuff with it. So, okay, well, for each character in, so we know that we've got in our game data, we know we have inventory data and we have, we can get the keys, so we can loop through the character names. So then we need to be able to link back up to the character. We could also be instantiating characters. So this could be a case where we could be then going from taking a prefab and instantiating it. In this case, we're finding and patching the existing characters. So there's different ways of working with stuff. And you might often need a mix of both. So you might be doing a bit of patching existing objects and in some cases, instantiating new ones. So then what I would be able to do in this case is, well, I've got that character, I know the character's name. So I could say find game object dot find, and I could find the one that has that particular name. I could also have a registry of characters. So for example, I could go and grab all the inventories. And actually, I think this is a way of doing this. If I grab the inventories, and then I could say, okay, well, if loaded data, inventory data, contains key, inventory, game object name, then inventory, and then my inventory data is equal to loaded data, but inventory data. So we restore the data to each character. Look up the data for this character. And then my actual player inventory one, I need to have a setter where data is equal to value. What I should find is I can now, just actually from the very beginning, I'll be able to restore stuff. So this we grab inventory, game object, name. So I should, just at the very beginning, be able to hit load, and I should actually have my data in there. Let's find out. We're running. We hit load. Well, we might have loaded it, but we didn't populate and tell it to refresh the UI. So that's something where after we've done a load, we actually need to tell our character panel UIs to refresh. So that's not an unusual thing where we would need to tell our UIs to refresh themselves at that particular point. So we could again find objects of type, character panel UI. So we could just directly notify them. Character panels, and then we would, for each panel UI and character panels, and then we would say, hey, panel UI, and then I might actually tell it to refresh, and I think I made that public, which I did, which is handy. Force the UI to refresh. So that's a common thing when we load. One of the things we're often going to need to do is be notifying our UI. Different ways of approaching it. In this case, I'm directly pushing that notification to the UI, but you could also have them be subscribing to notifications. So if we go load, we can see the items are there. Let's chuck in a couple more items. So this first character is going to have 4. Second one, let's make it that they've got 3 worn items, and then the other character has 3 carried items. So we save them, and then let's remove everything. So they have nothing. Let's load, and all the items are back. So saving and loading, like of this, we're saving and loading to a JSON file format. We can also use binary file formats. The difference there is that a binary file format is significantly less human readable. It is, however, typically going to be faster to load from and to save to. So for very large amounts of data, a binary file is definitely going to be a better option. But there are further considerations we need to make there if those files need to transfer across platform, because different platforms represent numbers in different ways. So that's just something to be aware of, that binary files are an option there with that. Generally for save files, especially during the early stages of development, I would very, very strongly recommend sticking with text files, in particular a format like JSON, because it's human readable. It means if something's going wrong, you can potentially easily find it. You can test out fixes by modifying the file. So early on, I would absolutely recommend using JSON for working with the particular files. Any structured file format, so you could also use XML. JSON is generally my preferred one. It's a little bit easier to read, I find, than an XML file, but any format is going to work. Key things we need to remember, though, is we need to generally split our data out from mono behaviors. So the mono behaviors, rather than we used to having lots of the state information just directly as variables in there, but we often, like we did with the player inventory, we want to split things out. We want to have it as separate ones so that we can actually then easily be working with it. We can save and restore that data. It means we can do things like when we load, we can instantiate prefabs based upon the particular character, and then we can populate their data that they need. We can, when we're working with stuff, as I said, we can be instantiating things, or we could be patching existing data. So we went an approach of patching, where we were modifying the ones that were already there. So which you use is going to depend upon the particular setup for your game, whether there's new things being added to the level or things being removed from it. If there are, then you need to go and do some instantiation. Otherwise, you can use this sort of more patching-based approach. With the Unity built-in serializer, it doesn't support inheritance. It doesn't support complex types like dictionaries, which means it's not going to be able to save and load a lot of your information without you doing a lot of extra jumping through hoops. So you're unpacking your dictionaries into 2 arrays and doing that for all of the data. It gets really messy and a lot of overhead adding that in. So what I do recommend is using something like Full Serializer, which is freely available. It's under the MIT license. There's a couple of tweaks we needed to make for it to work in the latest version of Unity, but it's a really solid package. So really strongly recommend that. If you're looking for something that is taking it a step further, that's got even more powerful serialization there, then one that I can recommend is one called Odin Inspector. It isn't free, so this is a paid asset. I have used it in a couple of my projects. It has some really great binary serialization as well. It also adds in a lot of extras to the inspector in Unity that are not there in the base version. It's really powerful. I do recommend it, but the cost is sort of a factor there. So be aware that it isn't free, and it does have a reasonable cost. But keep an eye out for it going on special. But for a lot of stuff that you're going to do, Full Serializer will do the job that you need. As I said, if you're going to use file formats, initially just stick with text file ones like JSON or XML. They're going to work a lot more reliably, and they're going to be better ones for during development. You can switch to binary later, or if you're running into performance issues, but early on for getting things up and running, use a text-based format. And yeah, so dive in and experiment with this. We already tested with some more complex types here in terms of our dictionaries and working with inheritance. There's a lot of extra types that the Full Serializer one adds in support for. So there's a lot of extra things it's going to be able to serialize there with the data that you're working with. So have an experiment with it. See the kinds of things that you want to be saving, and also test out using some of these tricks like pulling your data out into separate classes, but then using properties to make it that you're able to access them in the same way that you normally would. So good things to be practicing with. If you want to test out outputting to binary files, do that, but be aware that cross-platform stuff requires special consideration, because numbers are represented differently on different platforms at times. Something referred to as endianness. So some platforms are little endian and some are big endian, and it changes how the numbers are stored in memory. So you need to be aware of that if you're working with binary files. If you're needing to do a lot of binary stuff, I would recommend using a off-the-shelf asset like Odin Inspector. It's going to make it a lot easier for working with it. But dive in and experiment, see the kinds of things that you can be creating with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.